The first one is integral of x sine x dx. And the second one is integral of x e raised to power x dx. That is exponential function raised to power x dx. We are going to use integration by parts. So we have u dv is equal to uv minus the integral of v du. What is written on the board is the formula for integration by parts. What it means is that we are going to separate the function in parts, two parts. One, u. The second one is dv. Let me quickly do that. Let x be u, and let my sine x dx be my dv. So u dv is this, u dv. So the function is separated in parts, two parts, and it is given by the formula uv minus integral of v du. What it means is that in solving this problem, I need to know my u, I need to know my v, excuse me, I need to know my du. These three terms, I need to know them. So my u is here. U is equal to x. And to get my du, I will get that from differentiating u, and that is du dx is equal to 1, meaning that du is equal to dx. I have gotten du. Now, I have du, I have u, then what is remaining is to get my v. My v, I can get it from dv. So, dv is equal to sine x dx. What I will do to get this v is to integrate dv. And that means the integral of dv is equal to the integral of sine x dx. When I integrate dv, I get v. And when I integrate sine x, I'll get minus cos x. That means that my v is minus cos x, my du is equal to dx, and my u is equal to x. So, substituting into the formula, I will now have, therefore, my u is x, and my v is minus cos x, minus in the formula, the integral of v, which is minus cos x, then du here is equal to dx. Therefore, this is going to give me, multiplying minus cos x with x, I will get minus x cos x. Then minus times minus here will give me plus. Then the integral of cos x dx. So this is now going to be minus x cos x plus the integral of cos x is sine x, then plus c, the constant of integration. So this means that if I integrate x sine x dx, I will get minus x cos x plus sine x plus c as my result, as my answer. Now let's come to question number 2. Like I did here, let my u be x, and let my dv be exponential function raised to power x dx. So this is my dv. From the formula of integration by parts, which says u dv, that is u dv, which is the function separated into two parts, is given by this formula uv minus the integral of v du. So I will still do exactly the same thing here. My u here is x, so u is equal to x, meaning that du dx is equal to 1 and du will be equal to the x. Also, my dv is equal to e raised to power x, then dx, meaning that the integral of dv is equal to the integral of e raised to power x dx. When I integrate the v, I will get v. And when I integrate e raised to power x, I will get e raised to power x because that is the integral of an exponential function. So that is going to be e raised to power x. Therefore, also in this question number 2, I know my v in the formula, I know my du also in the formula, and I now have my u, which is equal to x. Substitution next. Therefore, my u is x and my v is e raised to power x minus, I now have it, the integral of v, which is e raised to power x, then the u here is equal to the x. What is now remaining is to take the final integration, which will now give my result as x e raised to power x minus the integral of e raised to power x, which is equal to e raised to power x, then plus c, which is the constant of integration. So I can factor out e raised to power x to get e raised to power x, that is exponential function raised to power x, into x minus 1, then plus c. Final answer. So we can simply say here that integrating x e raised to power x dx, my result will be e raised to power x into the bracket open x minus 1, bracket close, then plus c. Thank you.